Alright guys, we're going to go over incomplete dominance, codominance, and blood typing. So let's start with codominant. In codominance, both traits are expressed. Even though both traits are dominant, neither one is going to be dominant over the other, so they are both expressed at the same time. If you can notice in our diagram, we have a white chicken, both dominant, capital W, a black chicken, capital B, and then we have a speckled one, capital B, capital W. So you can see both black and white traits at the same time. And we would do a Punnett square, very similar to what we're used to. A normal Punnett square. So if we wanted to do this, we could take our first one, do capital W, our second one, capital B. Or you can write it as either way, because they have it as BW, but either way would be the same. So they're both expressed, you see white and black at the same time. The next one we have is incomplete dominance. So if you notice in our diagram, we have a white flower, we have a red flower. This time, the red is not really dominant over the white, and so you see a pink flower. There's kind of a blending. So again, you would do a same type of Punnett square. So if we did the one that's in the picture, we would have our capital R, little r. Instead of big R, little r being red, it is now pink because our red and white created pink. Sometimes you can also see it written with capital letters as well, so you could see it as capital R, capital W, because red plus white equals pink. So you might see it as capital R, capital W. Either way is correct as long as you understand that incomplete dominance is a blend, so we're making something new out of that. And so we're going to talk about our codominant again with our blood typing. So blood typing is a codominant trait, but it's also multiple alleles. Because if you notice, we have A blood type, we have B, we have AB, and we have O. And I chose this illustration because it's easier to understand that on our A blood type we have these little receptors, these protein markers that identify that this is an A type. A does not like B. They don't mix. A and B will kill each other. So if you have an A blood type and the doctor accidentally gives you type B, that is bad news for you because your A blood type is going to fight off B because B doesn't go there. They don't match. But an A could get an AB because they'd be okay. And the same thing, you can notice that our B markers here are different than that. O is kind of itself. O can go with any of these. It's kind of like a good guy, he just doesn't really care, he goes with the flow, so O can go either way. But we call this multiple alleles because even though this is type A, it can be written different ways. So A can be seen as A, or it can be seen as O. B is very similar. B can be seen as B, or BO. AB is only AB, O is only O. So you can write it as OO. So if we did some Punnett squares, let's say we have a mom who is A, and we know she's homozygous A, and we're going to cross her with a heterozygous B blood. So we would do our Punnett square. We know mom is AA, we know dad is BO. So we fill out our Punnett square. So you have a 50-50 chance, so 50% chance of the child being a B blood type, or you have a 50% chance of the child being a O blood type, or A blood type with the O as a recessive trait. In this case, again, I forgot to mention, the O equals recessive. So the only time you would see an individual with an O blood type is when they have two recessive traits, two O's together. So let's do a few more examples. So let's say we only know that dad has B blood type, but we're not sure what blood type he is, and mom is A. But we're not sure if she is homozygous A or heterozygous A. So we would have to do a couple Punnett squares. So if he is B, mom could be A, he could be B, mom could be O, he could be BO, mom could be AA, BO, or mom could be AO. So you would have to do multiple Punnett squares if you don't know if he's heterozygous or homozygous. So let's just say dad is homozygous, mom is heterozygous, to kind of make it easier. So B, we're going to cross AO. Do your Punnett square. Oops. So you have 50, and this would be for every child you would have. You'd always have a 50-50 chance of getting whichever blood type. Okay, so let's say we know dad is O blood type. And mom is A. So this time we're going to have to do two Punnett squares. So dad is O, mom is A, but we don't know if she is AA or AO for heterozygous. So we would fill out two Punnett squares for the possible genotypes. So this time they would have 100% chance being heterozygous for A blood type, or 50-50 for A or O. So that is how you do codominance, incomplete dominance, and blood typing, which is multiple alleles.